Hi, today we're going to be looking at a binomial expansions question. So the question here says that in the expansion of 3x plus 1 to the nth power, the coefficient of the term in x squared is 135n, where n is a positive integer. Find n. So before we proceed with these questions, there will be a couple of equations that we need. First one is the binomial expansion itself. We're looking for a specific term. So according to the equation, we can find the specific term by doing NCR times A to the n minus r power, and then B to the r power. We also need to find the NCR term itself. So we need to know the binomial coefficient. In this case, again, according to the equation booklet, NCR would equals to n factorial over n minus r factorial, and then r factorial. All right, so let's write down the questions. So we know that we're looking at 3x plus 1 to the nth power, and we're specifically looking for the x squared term. So the first thing we notice is that a is equals to 3x. That's the first term in the binomial expansion. We also notice that b is equals to 1. That's the second term in the binomial expansion. N is exactly what we're looking for, so we can't really replace that. So that's just going to be our n. So we're still missing r in this case. Now, if we pay attention, what we notice is that I need the x squared term. So obviously, I need to raise the first term to the 2 power. Now, you will also notice that for binomial expansions, we can actually swap these 2 powers. So it doesn't have to be a to the n minus r. We can actually rewrite this as NCR with a to the r power first, and then b to the n minus r power. That's because in a binomial expansion, it turns out that coefficient is symmetric. So if you come from the left or coming from the right, it's actually give you the same values. That's one beauty about the binomial coefficient. So having said that, because we need to get an extra term, so we can kind of see this r looks like it needs to be 2. So once we have all the ingredients, we can start plugging things in. All right, so we know that n in this case is just n. We don't know exactly what it is. The coefficients will have to be replaced with an r equals to 2. We know that a is 3x, so make sure we put a bracket around this whole thing. That's going to be raised to 2 power. b in this case is 1, and it's going to be raised to n minus 2 power. Now, what we also know is that the result of this particular term would have a coefficient of 135n. Not just 135n though, because we know that it comes from the x squared term, so that means the whole thing will be 135n x squared. This is very important. You don't write down x squared right now. We're going to not be able to cancel things in a little bit. So let's go ahead and see what we can do. So the first thing I notice is that 3x squared, when I expand that, that's going to give me 9x squared. So that's not too bad. 1 raised to n minus 2 power. Well, 1 raised to any power will still be 1. So we can write that down immediately. We still don't know what NC2 in this case is. So let's just go ahead and write down NC2 for the time being. And on the right-hand side, we still have 135n and then x squared. All right, so we can see in this case, I can cancel the x squared from both sides. So we can see that the x squared terms actually doesn't really play a big role. I can also divide both sides by 9 immediately to cancel out the 9 and make the right-hand side a little easier. So I end up with NC2 better equals to, so 135 divided by 9, in this case will give me 15n. All right, so now we can use this equation right here to find the binomial coefficient. So according to the equations, NC2, we can rewrite this as n factorial over n minus 2 factorial times 2 factorial. Now 2 factorial is just 2 times 1. So we still have the 15n on the side. So we can just think of this as just 2. And we can multiply by 2 on both sides to help us get rid of the 2. So the 2 will not cancel. And we can see that the right-hand side now becomes 30n. All right, that's very good because now we have the left-hand side we need to worry about. This is where most students will get stuck. They won't know how to actually simplify that. Now, it turns out what we need to do is we need to think about the n factorial on top as something we can peel off. Think about n factorial as you keep multiplying a number and it gets one smaller and smaller until we reach 1. So think about 5 factorials is the same as 5 times 4 times 3 times 2 times 1. But we can also think of 5 factorials as 5 times 4 factorial, or even 5 times 4 and then times 3 factorials. So that's exactly what I need to do. I'm going to think about n factorial as first n, and then the next smaller down, which is n minus 1. And then the next smaller number down, which is n minus 2. But we're going to stop there because you will see what's going to happen is that I also have a n minus 2 factorial on the bottom that we can use now to cancel out the whole thing. So what we really left with in this case is n times n minus 1 is equals to 30n. So let's expand that. So what we'll get now is n squared minus n must equals to 30n. So we have a quadratic. So what we need to do first is move everything to the same side, and we get some kind of 0 on the right-hand side. So that will help us be able to factorize it. So by moving the 30n to the left-hand side, we get n squared minus 31n must equals to 0. Now we can factor the n out from this equation, and we have n times n minus 31 must equals to 0. Using our knowledge from something called the no factor law, we can see that n is equals to 0 or n is equals to 31. Now, one of these answers doesn't work. In this case, n equals to 0 doesn't work because we were told that n has to be positive integers. And 0 is not a positive integer, so we can ignore this answer. And we're left with n must equals to 31.